And hello, welcome back. Welcome back everyone to this video of FreeCAD OpenFOAM Salome. So last video we actually talked about how to make such a shape. So assuming you know what this is, and you have done the stuff in FreeCAD, we can now export it to Salome. Of course, again, just want to re-emphasize, if you know all your steps in how to work with FreeCAD and Salome, just skip this. In this video we're going to do the meshing bit. After that, hopefully we do the OpenFOAM bit in a little while. Okay, just a disclaimer, the mesh we are generating now, it may or may not be stable, okay, in terms of numerical convergence, so there will be lots of trial and error. Okay, and the resulting mesh will look something like this. Okay, there are like 5 boundary layers at the side. Now, of course, I have not done my boundary layers properly, in the sense that I have not measured the Y plus when it comes off the wall, because you need to be very careful in how you select your Y plus. Okay, your wall shear stress needs to be taken into account. So, well, how do we get from this FreeCAD shape here, okay, to the shape over here? So this is one more worked example, and again I want to have actually a little bit more interesting, so a little bit more of an interesting shape, so that if I want to port this over to buoyant pimple foam, it will be okay. I can make one side meant to transfer heat into fluid, one side meant to transfer heat out of the fluid. So it makes it more interesting. Okay, more applicable to buoyant pimple foam. Okay, so first thing first, we have this whole heat exchanger with pipe. And what do? Again, we have to export as a step file. So I have one called heat exchanger with pipe, which I already exported it to, but never mind, I'll just save over it, heat exchanger with pipe, and I'll delete that. Okay, so let me open my video tutorial file. Yeah, discard everything. Alright, discard everything. I will delete everything in the geometry side. Okay, I'll delete, and I'll delete the mesh as well. Delete mesh 1. Okay, so I need to go to the mesh side and I'll delete mesh 1. Okay, algorithm, delete, hypotheses, all delete. So I'm starting basically with a very clean slate. Okay, so when I just have a very clean slate, I need to go to the geometry file. Alright, so I'll need to import my step file. So heat exchanger with pipe is here, and I will not take into account the millimeter units. I can, so that will just skip the transform point step. But that is it. Sketch 003. Oh great. I should not be having only that sketch. Okay, this is not intended. Let's try that again. Alright, let's get FreeCAD and alright, let's try again. Okay, export this whole shape, not just one small little shape. Then I'll import it into Salome. Over here. Yes. Oopsie. Show only. Ah, shucks. What's happening? Delete. Alright. Hold on. Okay, so let's try again. Alright, I think I have to be very careful. So select the whole shape, heat exchanger with pipe. We'll do the export function. Once you do select heat exchanger with pipe, I'll have to delete the .step file, and I'll save. Replace. And then once that is done, then I import the step file, heat exchanger with pipe.step. Okay, no, and that's not going to take the millimeter units in. So what happened just now was that I think I I left when I tried to export and I click this, I had a heat exchanger with pipe.step, and doing it like that will have a the file will be named heat exchanger with pipe.step. So there'll be two of those at the back. I think that's why it kind of messes up the file. So that's something we got to be careful with. Alright, so now we are back at this, so we'll need to quickly go through our shapes. Okay, so again, I'll have an inlet and outlet, so let's just define as follows. Let's do new entity, and then we'll need a new group. Okay, so we'll need to create group. Okay, I'll have this this called inlet. Okay, the main shape, I will need to select this whole thing. Now put it in here. Okay, exchanger with pipe. Okay, come on. Okay, so double click will work. Double click on the shape and it will work. Then I will need to select this, and then I'll call this the inlet, and I'll apply. I'll select this as the outlet, and I'll apply. Oopsie. Sorry, select this, add, and then apply. So you see there will be an inlet and outlet. Now I'll need to select this as the what do you call that? Hot side. Okay, I'll dump my heat there. I will call this hot side tubing. Alright, so that will, okay, I press enter by accident, click enter by accident, but that will show the hot side tubing. Okay, I'll show. Okay, so now the next part will be to do the cold side, the insulated walls, which will be every bit of tubing here except the tubes on the inside here. So that's one of the things. Let's do insulated tubing. Alright, let's do insulated tubing. So if we want to make our life easier, of course we can do this. Create group. Alright, insulated tubing. Alright, so what should we do as insulated? I guess we can add this. Show only selected height. Okay, select all. Oh right, I need to say it's a face first. Okay, so let's do this. Alright. Oh, I'll add this, I'll add this, I'll add this, this. Okay. I'll say all of these faces will be insulated. So if I want to see what I selected, then I will say show only selected. Okay, so if this is what you want, if this is what you want to be your insulated tubing, okay, show only selected. You want to say this is your insulated tubing, you can select all these faces here and you press show only selected, and that will show you the faces you have selected. So I'll just do that. And last one will be the cold side tubing. Cold side tubing. Alright, so what I can do is I select all, and another interesting trick for you. So you can actually select all the faces over here. For example, you can select inlet. You select inlet and it will appear in 104, shape 104. Select outlet, it will show here shape 19. Hot side tubing, it will show shape 89. Insulated tubing, it will select 3, 58, 84, 14, 69, 74, 94, 79, and 99. That's a bit of a mouthful, but anyway. So if I do shift and select, all of these will be highlighted, and I can just click remove and everything will be done, removed, and I can just click apply and that will become my cold side tubing. So what's cold side tubing look like? I can do this as a show only, and it will show me what the cold side tubing will look like. And as expected, it will be this array of pipes that we did in FreeCAD. So then what will the insulated side look like? Okay, I will show this. This is the insulated tubing. We don't want any heat, ideally, to come in and out of these these walls. All right. So you take a look here. You look at this. The hot side, the inlet, and the outlet. Oopsie. Woo. Okay, let's pan this. Okay, inlet and outlet, these are still open. So let's show outlet. Outlet will be here. So you can the flow can exit from here and go back here. Inlet will be here, and of course we have the insulated tubing. All right. So I can show this. Oops. Insulated tubing, cold side tubing, outlet, inlet, and hot side tubing. Of course, you want to color it different, sure. I can give this a red color. Okay, I can give this a red color, and then I'll give this a blue color. All right. Oops, that's black. That's not the color I want. I need a blue color. Yeah, blue color, please. Thank you. This blue color, so you can see where the heat is coming in and out of. Of course, if you want the insulated tubing to be black, I guess you could do that as well. So that's where you have your insulated tubing. This way, it's very easy for you to see what shape is which shape is which. And after that, you want to mesh, you go to your mesh side, and then under mesh, you'll put create mesh. Geometry, will select this heat exchanger with pipe. Okay, and we'll go for tetrahedrals. Okay, we'll do netgen 1D, 2D, and 3D automatic. I'll not be doing anything fancy. Okay, I'll leave the settings as default. Moderate fineness, min size as such, max size as such. So I will deal with all of that later. So I'll just apply. Of course, I can add the boundary layer hypothesis, viscous layers. So viscous layers, I can leave it as such. Total thickness maybe 2 mm. So these are in mm. Over here, number of layers 5, stretch factor 1.1. Okay, and I'll just select the inlet and outlet to be my parts with walls, and I'll just click OK. Apply. So I'll just delete mesh 1 because that was without the boundary layers, and I will rename this as mesh with BL's boundary layers. What I can do then is quickly compute. So I'm going through this meshing process very quickly because I've already gone through them in the past videos. So you can see how many volumes there are, 125,000, which is decent-ish, and you can see the meshes are being made okay, not too bad. All right, so this is the tetrahedral mesh that we want to export. Okay, if you want the polyhedral mesh, we may want to start with a more fine, a smaller tetrahedral mesh, and then we run polydual mesh on that. But I will export this first. Okay, so I'll just do tet. So I put tetrahedral. This will be for that, and of course I want to I want to copy. I want to copy one of these files over. So CPAR heat exchanger, salome BL experimental to heat exchanger. Okay, I'll do piped heat exchanger with salome tet BL. Okay, so I will save it. I'll save the file here. Of course, I will remove the what is the other one? What is this? Heat exchanger BL.unv. Okay, and I will just export there. Export it there. Where's the export button? Okay, should go on the file, export UNV file. Alright, so I will zoom into the OpenFOAM directory. Okay, I'll quickly export it to the OpenFOAM directory. SnappyX Mesh and FreeCAD. Let's put it under salome tab BL mesh. Okay, so be here. So that's one. Okay, shouldn't be too big. If you can check the size, it's exit. This is not the one. Yeah. How do I DUSH star? Okay, and we see that this text mesh is about 23 megabytes. Not too small, not too big. And if anything, it should be below 50. It should be okay for a Git upload. Alright, of course, let's see this salome, oopsie. Where is it? The salome file itself, how big is it? Alright, let's quickly go. Salome work directory. Where is it? This is my UNV files. Step files. Okay, the HDF files are here. DUSH star. That will list down all the sizes. Can you see the mesh test STL is very big. Video tutorial HDF, not that big at all. Okay, so I just save this file, and my video tutorial HDF file is only 7 megabytes. Of course, I can save my file there, and it will save actually a lot of space. So I might just do that. Alright, instead of leaving the files there, so you can play with the salome files. Shapes object files. Okay, salome. I'm going to save it here. Okay, save as all. I'll save it inside so you can play with the salome file yourself. Okay, shapes object file, salome video tutorial. Okay, heat exchanger with pipe. Okay, so now I also want to make a final tetrahedral mesh so that I can do a polydual mesh later on. Okay, so what can I do? I will change the hypothesis here. So instead I can go very fine. I'll change it to very fine, and I'll click OK. Viscous layers, let's give it a bigger thickness. Oh, 10 is too thick. Give me a 4. I don't want that thin a layer. This is hopefully so that you will get a thicker boundary layers. I'm trying to get the boundary layer thicker. Okay, I'm trying to get the boundary layer thicker so that I don't I don't run into the problem of having too thin a boundary layer later on, because what polydual mesh tends to do is that it will take the boundary layers and you'll make the thinnest layer even thinner because of the way the dual mesh is created. So how many elements do we have? About 600,000. Okay, it's very small. Okay, doesn't matter that my viscous layers are not reached, but this is the fine mesh, and it will be very much more space intensive. Let's see whether I can export this without causing too much of an issue. So during export mesh BL tet to UMV pyramids will be missed. Okay, I think since there's an error, I will have to do some adjustment. I'll make the total thickness maybe 2 mm again, or maybe 3 or 2.2. I'll give it less layers, maybe 4 layers. Okay, now let me try meshing it again. Hopefully it does not give me the same issue. Okay, so I'm almost up. Time is almost up for me. Okay, but let me see whether I can export this mesh and see how big. Yeah, so time is up. Let me see how much how many elements there are, how much of this meshing I can do. Okay, So it's gonna take a while because this mesh is ultra fine. Okay, so I'm just going to fast forward. So as you can see, there are almost 500,000 elements there, and it says mesh computation has succeeded. So this is exactly what we want. Unfortunately, this mesh will be very big. So let me export the UMV file first, and let's put it in here. Salome tet BL. So I'll put this as a fine. I'll leave it here. Okay, I'm going to copy. I guess I can copy this into this file here, dush star. You can see that that thing is 70 megabytes. It's not a small mesh at all. Alright, 90 megabytes now. So it's still exporting 108, 112, 119. Okay, it is still exporting. It's a very big mesh. So let me save this, and let's see how big this file is in the other folder. Okay, not in the salome work directory. Okay, I'm going to deal exclusively with OpenFOAM now. So shapes object files, salome, dush star, 41 megs. Okay, that's still palatable. Not ideal, but still palatable. Let's see, dush mesh fine tet. So 142 megabytes. That's pretty big file. Yeah, pretty big file. But for a fine mesh, this is to be expected. Okay, this is to be expected for a fine mesh. If we want a... Okay, I'll stop for now, and I'll continue in the next video. Okay, so hopefully this one of these meshes will be stable. I'll be able to run a polyhedral case with boundary layers, and I'll be able to run a tetrahedral case with boundary layers. I'm not going to use a hexahedral dominant mesh anymore, because these shapes are pretty irregular. Thanks for watching. I'll see you guys again. Bye bye.